Yeah, so like I said, 8.1 deals with polynomial functions and models. So y'all, before we begin this section, I'm going to give you a few definitions so that you'll know some of the things we're talking about in here. So since we're dealing with polynomials, we'll be talking about what we call the leading term. So the leading term of a polynomial is the term that contains the highest exponent. Okay, now remember, a polynomial, the terms are separated by addition and subtraction. Okay, so terms are separated by addition and subtraction, and the leading term will be the one term that has the highest exponent. So out of the leading term, we get two things. We get the leading coefficient, and y'all, the leading coefficient, that's the number in front of the leading term. Okay. And remember, if there's not a number in front of that variable with the highest exponent, then we treat it like a one, okay? Now, the second thing we get from the leading term is what we call the degree of the polynomial. So y'all, the degree of a polynomial is actually equal to that highest exponent. So the degree is equal to the highest exponent. Okay. So those are some terms we need to know when we're doing this section, because they'll say we'll have to know what degrees are and what the leading coefficients are so that we can tell what the end behavior of a graph is. So when we look at the end behavior of a graph, we're talking about what happens to that graph as those x values go towards negative and positive infinity. So the shape of the graph as the x values head towards negative infinity and positive infinity. So what happens as you go out them x values, okay? Now, based on the degree and the lead coefficient, we can predict what happens to those graphs as they head towards those infinities. So what we use is what we call an end behavior chart. Okay, and this will give us 4 diagrams that we can look at the degree and the lead coefficient to tell what our graphs will look like as they get bigger and bigger, okay? So y'all, the first thing we look at are the degrees of it. Does it have an even degree? Or does it have an odd degree? Okay, so we compare the degrees, and then we also compare the lead coefficient. So is the lead coefficient positive? Or is your lead coefficient negative? So let me put a plus here and a negative here. All right, so we draw a little T-shaped graph here. So first we look at the even degrees. If you have an even degree and the lead coefficient is positive, well, that's going to be like our parabolas, right? Both ends are going to go upwards. Now, in the long run, both ends will go upwards. Now, they leave a space here depending on what the degree is. So like an x squared would be just a straight up parabola, but an x4 graph might have a little bit of turns in here, or an x6 graph, okay? But the big thing is, if it's an even exponent and that lead coefficient is positive, as it heads towards infinity, both ends are going to go up. So what's going to happen if we make that lead coefficient negative? Remember, when we make the lead coefficient negative on a function, it takes that function and flips it over the x-axis. So if you got an even degree and the lead coefficient is negative, as those x's get bigger and bigger, headed towards infinity, both ends of these graphs will go downhill. So that's what happened when we did the negative x squared graphs, right? They flipped over and we had maximums. When it was positive x squared graphs, we had minimums. So that's the two cases if your degrees are even exponents. But what if we got an odd degree? So odd degrees are what we call odd functions, remember? And odd functions were symmetric to the origin. So if we got an odd degree that has a positive lead coefficient, these graphs are going to go uphill, left to right. Okay. And once again, depending on how big that odd exponent is, depends on how many turns we might have in here. So y'all, the last case would be an odd degree with a negative lead coefficient. Well, once again, that negative is going to take that function and flip it over. So if you flip this over, instead of this going uphill left to right, it's going to head downhill left to right. Okay. So keep this chart handy, especially for 8.1 and 8.2, because this chart can be used to predict which graph we pick on our answers, okay? So y'all, these ones will they'll start out by saying, so let's do one of these examples. It'll say select one of the following sketches that describes the end behavior. Of the graph. So here we are. They're giving us f of x equals square root of 2 x to the third plus 4x squared minus 4x plus 2. So, y'all, let's call this A, B, C, and D. So we'll choose one of these four pictures based on this graph. So, y'all, the two things I need to know is my degree even or odd? All right, y'all. So based on what we know about the degree, is the degree of this function even or odd? And remember, the degree is our highest exponent. So y'all, as we look through here, we got we got four terms. We got the square root of 2x third term. We got the 4x squared term. We got the negative 4x term. And we got our 2. So the leading term would be the square root of 2x to the third. So my degree is 3, which is odd. So my degree is odd. My lead coefficient is the square root of 2. Which is positive. So y'all, here's the question. We now have all the information we need to pick one of these four pictures. So if my degree is odd, my lead coefficient is positive, we go to the odd degrees, positive lead coefficient. So we would choose picture B. Our graph is going to go uphill, left to right. So they'll have four pictures of these four sketches, and we just pick the one that matches what we're given, okay? All right, y'all. So I'm going to try y'all on this next one doing that, okay? So let's see what y'all do with this. So y'all, once again, we're going to use end behavior diagram. To describe end behavior. Of the given function. All right, y'all. So this time they're giving me P of x equals negative pi x to the 6 plus x to the 5th minus x to the 4th minus x plus 1. All right, y'all, let me draw the four sketches real quick. So that'll be A, B, C, they're both going down. And then D, it goes downhill. So here's the question on this one. I want to know which one of these four sketches describes the end behavior of this given function. So you got to figure out the degree, and then you need to figure out whether that lead coefficient is positive or negative. So y'all, that's on y'all, A, B, C, or D. So let's see, we need our degree and our lead coefficient. All right, so I'm getting a C on there, so looks like you're doing good on that one. Because our degree is 6, is even. Our lead coefficient is negative pi, which is negative. And we said if it was an even degree, negative lead coefficient, both sides would go down. So this one, we would choose C. Okay. All right, y'all, same thing. Use the end behavior diagram to describe the end behavior of the graph. I got f of x equals negative 4.6 x to the fourth plus x to the sixth plus 0.2 x to the seventh. All right, so A, B, C, or D for this graph. So you got to figure out your degree and that lead coefficient. Is the lead coefficient positive or negative? So let's see. Oh, good job. I think you caught Nat, I think you caught the trick on this one. So the trick on this one was this ain't in order by degree. The degree is this 7 sitting at the end, right? So the degree is 7 is odd. The lead coefficient is the 0.2, which is positive. And we said if the degree was odd and the lead coefficient is positive, this graph would definitely go uphill, left to right. Okay. So y'all, that's the beginning of this. They're just hitting y'all with 4 problems where you have to look at the function and determine what this end behavior is going to do. So now we're going to look at how can we determine if a number is a zero of a function. So determining if a given number is a zero of a function. Well, y'all, the way we do that, we use what we call substitution. Okay, so to use substitution, first thing we do, we're going to set the function equal to 0. Then we will substitute the value given for the variable. And this is just a way that you can check yourself later on when we actually do these zeros. But I'm going to substitute the given value in for the variable. If this equals 0, so if the result is 0, then the number or the given value is a 0 for that function. So then the given value is a zero of the function. If you get any other number when you plug it in and it's not zero, then that means that the given number is not a zero, okay? So set it equal to zero, plug in for that number, and determine whether it is a zero or not. So y'all, let's go try this one. So we're going to use substitution to determine whether 2 is a zero of the following. All right, y'all, so my function they're giving me is f of x equals x to the third minus 11x squared plus 16x plus 3. So remember, to determine if 2 is a zero of this, I basically got to set this equal to 0 and plug a 2 in for all the x's. So we will have 2 to the third minus 11 times 2 squared plus 16 times 2 plus 3. This has to equal 0. So if the left side equals 0, then I got a yes on this. If this left side equals anything else, then we're going to put no. So y'all, let me just start out. I'm just going to do the exponents first. So 2 times 2 times 2 is 8 minus 11 times 2 times 2, which is 4. And y'all, I'm just bringing everything else down. So all I wanted to do on that step was the exponents, okay? Now I'm going to do the two places where I got to multiply. So I'm going to have my 8 minus 11 times 4 is 44. Plus 16 times 2 is 32. And then plus my 3. All right, y'all. So now we're just adding and subtracting. 8 minus 44 is a negative 36. Negative 36 plus 32 is a negative 4. Negative 4 plus 3 gives me a negative 1 equal to 0. So y'all, since we didn't get a 0 on this side, on this one, we would put no. Okay, since I didn't get a 0 answer on that, then that means it is not a 0 of that function, okay? And y'all, that's a trick. That's how you can check your numbers when you're finding zeros. If you plug them back into the function, it's actually got to equal 0 to be a 0, okay? All righty, so time for another definition. So we know what zeros are. Those are the solutions to the functions when you set them equal to 0. They're also equal to the x-intercepts, x values. So a new word we're going to look at is what we call multiplicity. So y'all, when we talk about multiplicity of zeros, So the multiplicity of a zero is how many times that zero occurs. Okay. So here's the thing. If if the zeros are in factor form, so if in factor form, using parentheses, the multiplicity is equal to the exponent outside the parentheses. So if you're in factor form like x plus 2 inside parentheses, then the multiplicity will be the exponent on that outside of those parentheses. Now, if you got a single variable, then the multiplicity is equal to the exponent of that variable. But y'all look here, no matter how you look at it, the multiplicity is equal to the exponents, okay? Whether they're in parentheses or whether they are single variable terms, okay? So on these examples, they're going to want us to find the zeros. So we're going to find the zeros and state the multiplicity of each. Okay, so sometimes they give them to you in factored form, which the first few examples will give us. And then later on, they're just going to give us a polynomial, and we actually got to factor it to find our zeros, okay? So like I said, they're going to start out factored. So for this one, I got f of x equals x to the 7th times x minus 2 squared times x plus 7. Now, what we got to realize on this problem is that we got three factors. Since it's already factored, I got the x factor, the x minus 2, and the x plus 7. So this one's already factored. So what we do is we set all three of these factors equal to 0. And y'all look at that. Anytime you got a single x like that with exponents, when you set it equal to 0, it's done. So anytime we have a single variable like that, its 0 is 0. Now the other two, we're going to set them equal to 0. Okay. So now we'll solve these by adding 2 to this one. And again, x equals 2. So remember, the zeros are always opposite in sign than the factors. So since this was a positive 7, our 0 will end up as a negative 7. All right, so I got my 3 zeros. Now here's how they do the answers on this one. Okay, so watch how they're doing these answers. The smallest 0 is blank with multiplicity blank. The middle 0 is blank with multiplicity blank. And y'all finally, the largest 0 is blank with multiplicity blank. All right, you got 3 zeros. You got 0, 2, and negative 7. Of them 3, which one's the smallest? All right, so let's see. You got negative 7, so good. All they want on that is actually the negative 7. Good job. Now, we need to know what the multiplicity is of this 0. Well, y'all, this 0 came from this last factor, the x plus 7. So here's a question. There's not an exponent out here. So if there's not an exponent outside these parentheses, what do we treat it like? Anytime y'all don't see an exponent, it is definitely a 1. Good job. So y'all, you got to treat that like a 1 out here because this factor only happened 1 time. So that means the 0 of negative 7 has a multiplicity of 1. So y'all, next question. What's the middle 0? So the middle 0 is 0. Good job. So the 0 is right here. So what is its multiplicity? And that's 7. So see, that'd be the single variable. And we said on the single variable, the multiplicity was equal to its exponent. So good job, y'all. So that means, y'all, what is my largest 0? So Jackson, what are y'all putting? 2. Good job. And what is this multiplicity? So good job, y'all. It is also 2 because the 0, 2 came from the x minus 2 factor and it had an exponent of 2. So y'all, good job. So let's play with some of these for a little bit and see what y'all do, okay? All right, also same thing. We're finding zeros and the multiplicity of each. This time they're giving us f of x equals negative 4 times x minus 3 squared, x plus 4 to the 4th, and at the end is an x to the 3rd. Now, y'all, I want y'all to realize on this problem, although they got, 4 factors, we're only concerned with 3 of them. There's no way you can take a constant number like this negative 4 and set it equal to 0 because it does not have a variable with it. So when they give you this single number out in the front, you might as well cross that thing out because it has to have a variable to be a 0, okay? So notice, I got 3 factors actually, not 4. So I would set x minus 3 equal to 0. I would set x plus 4 equal to 0. And then on my single term, I would set x equal to 0. We're going to solve all three of these. So the first one, I'll add 3. So we get x equals 3. The second one, I guess we'll subtract 4. Get x is a negative 4. Once again, the single variable gives me 0, okay? So let me show you how they write this answer. The 0, 3 has multiplicity blank. Then they say blank is a 0 of multiplicity 4. And then finally they say the remaining 0 is blank. It has multiplicity blank. So y'all, I need y'all to help me fill this in. So the 0, 3 has a multiplicity of what? All right, Eva, what y'all got going on there? You and Nat got 2. So the 0, 3 came from this factor, which definitely, good job, has a degree of 2 or multiplicity of 2. So then how about this? Blank is a 0 of multiplicity 4. Oh, Macy, you're so close. So let's see, what's even? There you go, y'all. Remember, we want the 0, not the factor. So the 0 actually was, y'all got that now? So negative 4. So y'all, what about this one? Fill these two blanks in. The remaining 0 is blank, and it has a multiplicity blank. So what are y'all putting in them two spaces? And see, y'all done taken care of the 3 right here and the negative 4 right here. So what's left? What is my last 0? So it is 0. Good job. Oh, you got a question mark there. You don't need that question mark because that thing had a multiplicity of 3. Good job, Eva. So that's the trick on that one, okay? But y'all remember, those ones were already factored for us, okay? Well, sometimes in life, functions are not factored for us. So let me show you one right here. They want us to find the zeros of the function. And their multiplicities. So y'all watch this one. Here they're giving me f of x equals x to the third minus 4x squared minus x plus 4. So y'all, we need to do what I call factor by grouping on this one. Have y'all ever done factor by grouping? And that's really the easiest way when you got 4 terms like this. So we're going to do what we call factor by grouping. So I'm sort of going to write my steps over here while I'm going through this, okay? So where it gets its name factor by grouping is because we got 4 terms here. We're going to factor this into 2 groups. Okay. So we group the first 2 terms together and the last 2 terms together. All right, well, we got them in their 2 groups. Next, what you're going to do to these, you're going to factor out the greatest common factor for each group. Now, we'll say this. The second GCF has the same sign as the third term. Okay, so the third term is negative x. That means the second GCF of these 2 will be negative like that. All right, y'all, so here we go. Let's put these first 2 terms together. We're going to factor out the GCF of these first 2 terms. So, y'all, what's the most they got in common? You got an x3 here. You got a 4x squared here. The most that they have in common is the x squared. Because this one has at least 2 x's. This one has 3 x's. So we both have at least 2 x's in them, okay? So what I'm going to do, I'm going to factor out an x squared. What's left when we take an x squared out, we put in the parentheses. So y'all look here. X to the third. You take out an x squared, that's going to leave you an x minus. Well, if you have a 4x squared, you take out the x squared, that's going to leave us a 4. All right, y'all, check this out. We said the second GCF is going to be negative because that third term is negative. And y'all look at this. I got an X and a 4. There's only one thing in the world that they got in common as a factor, and that would be a 1. So the second GCF, you at least have to factor out a 1, okay? Well, this -1, all it's doing is changing the signs. Negative divided by negative makes that a positive x. And then 4 divided by -1 makes that a -4. So y'all look at this. At this point, these parentheses have got to be equal. So the last step is putting these in their own 2 sets of parentheses. So here we factored out the GCF. Then, check this out. You got 2 terms here. You got the x squared times x minus 4. You got the 1 times x minus 4. Both of these have a x minus 4 in common. So you would factor out that x minus 4. The second parentheses is what's left. Well, what's left when you factor out the x minus x squared, the x minus 4s is the stuff on the outside, which is the x squared minus 1. So y'all, the inside stuff makes 1 parentheses. The outside stuff makes the second parentheses, okay? So at this point, what do we do? We factored out the parentheses. as a greatest common factor. Okay, so technically we factored out GCFs here, got to x squared and -1. Once we got to this point, since the parentheses matched up, we factored them out as the greatest common factor, and then the x squared minus 1 that was left became my second factor. So y'all, that's factored by grouping. Now this is factored form. So this is now factored form. So here's the trick. So this is now factored. So to find my zeros, I'm going to set each one of these factors equal to 0. All right, so now you got that going on pretty good there, don't you? X plus 1, x minus 1, x minus 4. So yeah, you've got this all the way factored. So on these ones, I'm going to show y'all another trick to solving them if you don't like factoring. But this one we can solve by adding 4 to both sides. And y'all get x equals 4. Now on this one, I'm going to show y'all another trick. When you got an x squared in a number, I can solve them by doing square roots. So I'm going to add 1 to both sides. I get x squared equals 1. And then to solve this, I'm going to take square roots of both sides. But y'all remember this. When you take a square root of a number, you need to use your plus or minus, because the square root of 1 could be a positive 1, but also the square root of 1 could be a negative 1, because -1 times -1 equals +1. So remember, since we did that quadratic formula, anytime I take the square root of a number, I got to account the positive and negative of both of those. Because remember, you get 2 zeros when you got an x squared. Well, my 2 zeros would be 1 and -1. So y'all, for this problem, you would list your zeros. So the zeros are going to be x equals 1, -1, and 4. But y'all, here's my question. Each zero has multiplicity what? Well, here you go. Remember, right here was my factored form. And I don't have any exponents outside these parentheses. So now what you got, a 1? Correct. Because remember, there's one of these factors and there's one of those factors. So I go back to my factored form to find my multiplicity. And since our parentheses didn't have numbers out there, they were definitely a 1. Okay? All right, y'all. So that's the trick on those. All right, y'all. So I'll do one more of these and then we'll knock out our break. How about that? All right, y'all. So I'm going to do the same thing. Find the zeros and their multiplicity. All right, also let's see on this one, I got f of x equals 6x to the third minus x squared minus 294x plus 49. All righty. So I'm going to do the same thing, factor by grouping. I'm going to factor my first 2 terms together and my last 2. So these are really similar here. I got a 6x to the third and an x squared. Their GCF will be the x squared again. So if I factor out an x squared from both of these, I'm going to have a 6x left in the front. Minus, well, y'all, x squared divided by x squared is a 1. Second GCF is going to be negative, like that third term. Now, here's the trick. These are big numbers. But you need to end with a 1 at the end. So if you want to turn that 49 into a 1 to match these parentheses, that means that GCF of the second set of terms has to be 49. So 49 will divide into both of these numbers. So y'all, here we go. A negative 294 divided by a negative 49 leaves me 6x. And then 49 divided by negative 49 gives me my negative 1. So on this one, that last number on this one is usually the GCF, okay? All right, so remember what we said at the end. The stuff inside the parentheses matches up. So that becomes pulled out like a GCF. And if I pull out the 6x minus 1, what's left here is the x squared minus 49. Oh, at this point, we're factored. So if we wanted to add our exponents at this point, both of these happened one time, so their multiplicities will be 1. Now, y'all, are y'all noticing that the biggest exponent is telling me how many zeros I get every time? Up here, I had an x3. I got 3 zeros, 4, 1, and negative 1. Here we had an x3. We're going to get 3 zeros, okay? So set 6x minus 1 equal to 0. And then set x squared minus 49 equal to 0. All right, so look here. This will give me one of my zeros, and this will give me the other 2, okay? So y'all, for this one, we're going to add 1, and then we'll divide by 6. So 6x equals 1. Divide both sides by 6. And x equals 1/6. On this one, it's similar to this. I got an x squared in a number. So I'm going to add my 49 and do my square roots. All right, so then we would come in and do square roots to both sides. And y'all remember, I'm doing the square root of a number, so I'm going to use a plus or minus. So the square root of x squared is x. Square root of 49 is a plus or minus 7. So our zeros are what do we get? 1/6, 7, and negative 7. Now, MATLAB will let y'all use the plus or minus on that if you don't want to write it twice, okay? All right, each has a zero of, each has a multiplicity of, and y'all, we said each of these would have a multiplicity of 1. So that's how many times each of them factors happen. So y'all, that's the trick. On the earlier problems, they had them already factored out. So we just set the factors equal to 0, and then we looked at our exponents for our multiplicity. When you got 4 terms like these, you actually got to factor them. And once you get them factored, then solve for your zeros, okay? All right, y'all, so we're going to take a break. And when we get back, there's a couple more problems we're going to look at in this section. And then we'll knock out 8.2. Now, 8.2 ain't bad. It's not as tricky as this section, okay? So y'all, let me find my pause. All right, y'all, so 10:56. So how about we take our break till 11:06, and then we'll come back and pick up with the rest of this, okay? All right, y'all, looks like 11:06. So we got two more questions in 8-1, and then we'll knock out our 8-2, okay? So let me get us resuming on our recording. All right, y'all, so the last two deal with when we look at zeros, we want to know whether they cross over the x-axis or whether they come down and touch the x-axis and turn back up. We call that being tangent. So there's two things we look at, and that is the multiplicity of those zeros, okay? So on the zeros, if the zero has a positive multiplicity, then whoops, y'all can't even read that, y'all, my bad. So if the zero has a positive multiplicity, then the graph is tangent to the x-axis. At that zero. So y'all, what that means is, say I got a graph here. So that means the graph will come down. It sort of touches the x-axis and then it turns up. It does not cross over the x-axis if the multiplicity is even or, okay? Oh, so here, make this even, y'all, my bad. I was thinking positive. But if it has a even multiplicity, the graph is tangent to the x-axis at that zero. So that means if it has an odd multiplicity, so if it has an odd multiplicity, then the graph crosses over the x-axis at that zero. Okay, so if you had your graph here, so that means that your graph would come down and it crosses right on over that x-axis, okay? That happens if it's an odd multiplicity, and it's tangent here if it's a even multiplicity. So these last two questions were true or false. So y'all, this first one, if P of X equals X minus 7 to the 8th, and then X plus 8 to the 7th, then the polynomial crosses the x-axis at the point 7, 0. So I'll show y'all how to do this one, and then I'll let y'all answer the next one. How about that? So we're looking at the 0 of 7, basically. Well, if one of these two factors will give me a 0 of 7, and that's this x minus 7 factor. It has a multiplicity of 8. So since this polynomial has a multiplicity of 8 at this 0, remember we said if it was even, it was tangent to the x-axis. Well, they're saying that it crosses the x-axis at this point. So this one would be false because the multiplicity of 8 is even. Now, y'all don't got to put the reason. You're just saying, yeah, it does have reasons on this one. So we would say because the multiplicity of 8 is even, okay? So y'all, true or false on this one? If P of X equals X minus 2 to the ninth times X plus 1 to the fourth, then the polynomial is tangent to the x-axis at the point -1, 0. So is that true or false? All right. Oh, I'm getting y'all on this one, y'all. So look here, you got a 0 of -1 they're talking about. Well, y'all, that -1 came from this factor, x plus 1. It has a multiplicity of 4. Well, remember, up here we said if it had an even multiplicity, then it is tangent at that 0. Well, they're saying that the polynomial is tangent at that 0. So this one is actually true. And that'd be because the multiplicity of 4 is even. Thus, it is tangent, okay? So remember, odd multiplicities, it does cross over. Even multiplicities, it's going to be tangent. So if we was looking at these, this factor would give me a 0 of 2. 2 would have a multiplicity of 9. So at this 0, it does cross over. But this one would give me a 0 of -1. And like we said, since it was even, it came down and just sort of touches it, okay? All righty, y'all. So that is 8-1. So we about to get into 8-2. Now, 8-2 is not too bad. We sort of do some graphing in there. And on some of these, I'm going to show you how to set the window because they give you the numbers they want you to set the window on so that you can see the graph, okay? Because sometimes the standard 10 by 10 window don't show enough of the graph to see what's happening in the big picture. So they give us um, the graphs and we can set the windows on them, okay? But before we do that, we're going to look at how to find what's the maximum number of zeros a polynomial can have, what's the maximum number of x-intercepts they can have, and what's the maximum number of turning points these polynomials can have. Okay, so the max, okay, so whoops, this is 8.2, and this deals with graphing polynomials. So the maximum number of real zeros is equal to the degree. So whatever that highest exponent is, that's the degree. So the maximum number of real zeros I could have would be equal to that exponent. So like we'll always doing the x to the third. That means that I will have 3 zeros. Now, they might not all be real zeros, but the maximum number that I could have of real zeros is 3. Sometimes I might have a real zero and 2 imaginary zeros, okay? But the maximum number of real zeros I could have is equal to the degree. Well, what about this? The maximum number of x-intercepts. We said that x-intercepts were basically the same thing as zeros, right? We had that picture where you had to find the x-intercepts and the zeros. So since x-intercepts are basically the same as real zeros, the maximum number of x-intercepts is equal to the degree again. And y'all, these two are always going to be the same, okay? If it crosses 3 times and has 3 zeros, then it's going to have 3 x-intercepts. Now, the reason it's the maximum number of x-intercepts, because sometimes if you have imaginary zeros, they don't cross over the x-axis. So that's why we say the maximum number of x-intercepts. Now, the last thing I can get from that degree is the maximum number of turning points. So the maximum number of turning points is equal to the degree minus 1. Okay, so real zeros equal to the degree, x-intercepts equal to the degree, turning points equal to the degree minus 1. Remember when we did the x squared graphs, we did parabolas? Well, 2 minus 1 gave me 1 turning point here. When you did the cube graphs sort of come up and go uphill. Well, guess what? For x3, you subtract 1, that gives you a turning point here and a turning point there. So if you subtract 1 from the highest exponent, that tells you how many times your graph is turning, okay? So y'all knowing this, they want us for each function f of x, they want us to find the maximum number of real zeros maximum number of x-intercepts and the maximum number of turning points. All right. So for my number 1, they're giving me f of x equals x to the 4th minus x to the 3rd plus 2. So we want maximum real zeros, maximum x-intercepts, and maximum turning points. All righty, so the question of the day. What is my maximum number of real zeros? And remember, that is equal to the degree. So the question is, what's the degree of this polynomial? So what we would look at, what's my highest exponent? Nat, what you got, a 4? Good job. So since the degree is 4, the maximum number of real zeros is 4. Now, although it's the maximum number of real zeros, 4 is the number of zeros you'll get, whether they're maximum or imaginary altogether, okay? They could be all real, but altogether you will have 4 zeros on that, no matter what. All right, y'all. What do we say would be the maximum x-intercepts? And guess what? That is also equal to the degree. So what do y'all put? 4. Good job. Because zeros and intercepts are the same. And how about my maximum number of turning points? Oh, y'all look here. Equal to the degree minus 1. Oh, Nat, do this. Take your degree 4 minus 1, and that gives you 3. Good job. Okay? So the degree gives you 2 of them. Subtract 1 to get the turning points. All right, y'all do that on this one. F of x equals negative 9x minus x squared. So once again, I want the max real zeros, max x-intercepts, and then my max turning points. All right, y'all, for this one, what would y'all say is my maximum real zeros? All right, so 2, because 2 is my highest exponent. Just watch out, they're out of order, okay? But 2 is my highest exponent, so that's my degree. All right, y'all, how about the maximum x-intercepts? All right, y'all, so I'm getting a little delay, but it looks like y'all are starting to put a 2 on that. Good job. So the final question, maximum number of turning points. And that would be 1. Good job. All righty, y'all, so the first 4 are just doing that, okay? Actually, the first 3. At number 4, they start giving you questions like, um, match the graph to the function. All right, y'all, so here we go. F of x equals 1/2 x squared minus 1. Now, I'm going to show you 4 pictures here. So let me zoom this in just a little bit. Whoops, wrong button. All right, y'all, so I'm messing with this function. 1/2 x squared minus 1. They give me 4 graphs. Now let me tell y'all something. While ago, we did the end behavior stuff, remember? So what did we say about a graph that had an even degree and a positive lead coefficient? So I got an even degree and a positive lead coefficient. Would y'all pick the graph that's going uphill left to right? Would you pick the parabola that's flipped over? Would you pick the parabola that opens up? Or would y'all pick the graph that goes downhill left to right? Whoa, y'all getting on there quick. See, exactly. Y'all remember we said if it was even with a positive lead coefficient, we said that in the big picture, both ends were going to go up. Well, y'all, only one of these graphs has both ends going up, and that would be your C on that one, okay? Now notice, we can graph this, and it's using a -10 to 10 scale on it. So let's just go graph it and look. So we could go to our calculator and go to y equals, and I'm going to put in my 1 divided by 2, x squared, what was it, minus 1. So there's our actual graph of the function when I hit graph. And y'all look at that. It does look like that graph C, a opening parabola that's opening upward, okay? All righty. So we know this one in the long run basically came down just a little bit and turned up. All right, so let's try this one. F of x equals x to the 5th minus x to the 4th plus x squared plus 12. All right, so I'm gonna give you 3 pictures on that one. So y'all are giving me these 3 pictures here. So this is your x5 term. Your degree is odd. Your lead coefficient is 1 right there. So it's positive. So would we pick A, B, or C when it's an odd degree and the graph is positive? That what y'all, I see something popping up. B, good job, because remember, if it's odd and positive, it's going to go uphill, left to right. Okay, so the only one doing that would be B for sure. Now, y'all, I'm going to show you how to. You see this stuff right here? All graphs, -5 to 5, -50 to 50. These are the x values. This would be your x minimum value, x maximum value, and then your y minimum and your y maximum. And then they're telling you the x scale is 1, the y scale is 10. So let me show you how to get to this stuff. On the graph, so let's go to our graph, and I'm going to show you how to put these numbers in so that you can match these graphs perfectly. So we go to our graph and calculator. All right, I'm going to go to y equals and clear everything off. So my actual function was x to the 5th. So x exponent 5, arrow down, minus x to the 4th. So x exponent 4, arrow down, plus x squared. So x squared plus 12. Now remember, they said all graphs, negative 5, 5, negative 50, 50. So you're going to go and hit the window button because they're telling us what to set the window to get our graphs to look like theirs. So X minimum, they said, was negative 5, enter. X max was positive 5, enter. My X scale, they said, was 1. But my Y minimum was a negative 50. My Y maximum was a positive 50. And then they said on the Y scale, go by 10. So this means the X scale and Y scale is how much is in between each tick mark on that graph, okay? So y'all, here's the thing. We now got our window matching theirs. So when we hit graph, oh, there you go. It exactly looks like B, okay? Now, let me show you this. Say you want to set your graph back to a 10 by 10 window, and you don't want to have to go back to the window and reset everything negative 10 and 10. If you want to set it back to a 10 by 10 graph, you hit zoom, and then you go down to number 6 that says standard. This will set it back as a standard 10 by 10 graph when you hit enter. Now notice, you can't tell what's happening with this graph. That's why they wanted us to do negative 5 to 5 and then negative 50 to 50 on the X's and Y's. Okay. So y'all, this is but I was just showing you mainly how to set it back to a 10 by 10, okay? Whoops, my clicker's not clicking. All right, y'all, so that's the trick on that one. Let's see on this one. Oh, this one I got f of x equals negative x to the 5th minus 3x to the 4th. Now, y'all, this one don't give you the window stuff, but I will say this. If you look at the 4 graphs they have, you'll see that the x's are going from negative 10 to 10, and the y values are going from negative 100 to 100. Okay? Now, I'm doing this one right here. You got 4 pictures, almost parabola, downhill, uphill, and an upside down parabola look. That is a negative x to the 5th. You got an odd degree with a negative lead coefficient. Would y'all pick A, B, C, or D? So that B, whoops, where am I at? Definitely. Because remember, if it's odd with a negative lead coefficient, we said that those go downhill left to right. And y'all, B is the only one that goes downhill left to right. Now, let me graph it. I'm going to set my window to match theirs on this one so that we can actually see the graph good. So I'll go to Y equals and clear that out. So y'all, we had negative x exponent 5, arrow down, and that was minus 3x exponent 4. So I got my function in. Now remember, I'm going to set the window to match theirs. So the x's went from negative 10 to 10, so I'm good on those. But my y values went from negative 100 to a positive 100. And it looked like they was going by 10 on that. So you can just sort of estimate what you think they're going by on that y-axis, okay? But they only had 10 marks, so I figured they was going 10, 20, 30, and so on. All right, y'all, let's graph it. We said B, which went downhill, and y'all look at that. B is going downhill, okay? So y'all want to do one more. Um, so notice all these were polynomials they gave us. Watch this one. We got h of x equals x times x minus 2 times x plus 1 times x minus 3. Now this one's factored, so it's sort of harder to tell what's happening. But y'all, let me show you this. If you just multiply all four of these x's, that would give you an x to the fourth. And all the x's are positive. So that would give you a positive x to the fourth. Now I'm going to show you my picture down here I'm playing with. I'm playing with this one right here. Okay. X minus 2, x plus 1, x minus 3. So, like I said, you can multiply all the x's together and you would get an x to the fourth, which is even and positive. So y'all, in the end, even in positive, we should get a picture like B, right? So I'm going to go set my calculator. And I think the problem before I had negative 100 and 100. So let's go punch that in on it and see what it does. So I'm going to clear this out. All right, y'all, so we had x times parentheses x minus 2 times x plus 1 times x minus 3. Now I'm going to hit my window because I think it's already set like I needed it. Yeah, they went from negative 10 to 10, and then they went negative 100 to 100. I'm just going to leave my x scale and y scale like that because it really don't matter. You can make that whatever you want on those. All we want to do is hit graph. And y'all, there it looks like that B y'all picked. Okay. Now, if you was to zoom this in just a little bit, I want y'all to see what's happening at the x-axis. See, these graphs are actually crossing over and then coming back up, and then it crosses over and comes back up. It's crossing over the x-axis because all those multiplicities are odd. Okay. Also, that is basically your 8-1 and 8-2. Okay. So what I'm going to do real quick to get y'all ready for 8-3, I'm going to give y'all a preview of 8-3 real quick, okay? And really what I'm going to give you a preview for is what we call synthetic division. Okay. Now, I'll tell you what we use synthetic division for tomorrow. Like we use it to find function values We can use it to determine if a number is a zero or not. We can use it to find quotients and remainders. Okay. So I'm going to show you just one problem to get you used to synthetic division for finding function values. So I'm going to find f of 2 given f of x equals x to the third minus 13x squared plus 52x minus 60. So have any of y'all ever done synthetic division? So y'all, it's something we use instead of long division. Long division, woo, you can lose stuff quick. But synthetic division is not too bad. So let me write my steps over here. That way I can give y'all the steps today, and tomorrow we'll just start working problems, okay? So the first thing we do, we write the coefficients, right? The coefficients of the polynomial. Now, when you write these coefficients, if there's any missing terms in our polynomial, so let's see, we got an x3 term, x squared term, x term, and we got our number at the end. There's nothing missing in this because we got the x3, x2, x, and our number. If there was stuff missing up there, we would use 0 for any missing terms. So say they gave me an x3, 52x, and 60. If I didn't have the x squared term here, I would have to use a 0 for its coefficient. All right, so the first thing we're going to do, write our coefficients. We got a 1, negative 13, 52, and negative 60. Now, I'm going to draw a line under this, draw a line, leaving space under the coefficients. And I'm going to make a box under the last number. Okay, so you're going to come in, leave a little space in here, come in and draw you a line, and then we're going to box under the last number. Y'all, what this box is, it gives us the remainder or the function value. So this box is the remainder or function value. All righty. Next, we're going to write C to the left. So over here, I make like a half a box. And this is where I put my C. C, when you're finding function values like this, C is equal to the number you're finding the function value of. All right, so my polynomial gives me the coefficients. The function value is equal to my C here. So now we're going to work this using what we call synthetic division. So the first step of synthetic division, you're going to bring the first number down below the line. All right, so my first number is a 1. I'm going to bring it straight down below that line. Now, what you do, so let me get us some more space here. So now, you're going to take the number you brought down, and multiply by C. You're going to put that answer into the next column. Under the second coefficient. Okay, so we're going to multiply this number we brought down times C. So 1 times 2 is 2. We're going to put that into the next column under the second coefficient. So that's why we had to leave space here. Because our numbers, when we multiply by C, we're going to put under these numbers here in our spaces. All right, y'all, the next step. One, the new column. And write answer below the line. All right, y'all, so let me bring this back up a little bit. Negative 13 plus 2. We're going to add them together and see what we get. Well, y'all, negative 13 plus 2 gives me a negative 11. And I brought that number below the line. So guess what I'm about to do? I'm going to repeat the process until done. So we're just going to keep repeating this process until we're done here. So guess what? This negative 11 is below the line. We're going to take that negative 11, multiply by 2, and put that answer in the next column. So negative 11 times 2 is negative 22. Now, when they're in a column together, we're going to add this. So 52 and a negative 22 give me 30. All right, so I brought that number down below the line. Since it's below the line, I'm going to multiply by C to get my next number. So y'all look here. 30 times 2 is 60. So when I add these two together, I will have my function value. So a negative 60 plus 60 is 0. So that means f of 2 equals 0. That is the answer that you would have got if you would have put a 0 in for this function. I mean, not a 0, but a 2. If you'd have put a 2 into this and worked it, you would have ended up with an answer of 0, okay? So y'all, that's a preview of what we got coming up tomorrow with 8.3. We're going to be doing synthetic division. And like I said, I'm going to show you how we use it to find function values, which is what I did here. I'll show you how to tell whether a number is a 0 or not. Well, y'all, guess what? If a number is a 0 of a function, then its remainder has to be 0. And then I'll show you how to find the quotient and remainder when you do division, okay? So So y'all, that was just a preview. Just wanted to let y'all see how to sort of work it. So tomorrow we'll go through the steps again and actually do 8.3, okay? All righty, y'all. So let's see. Did y'all have any questions on today? All righty. So tomorrow we start out at 8.3. We're going to do 8.3. We'll do our synthetic division. 8.4, we're going to be doing more zero stuff. So we're going to do a little bit of foiling on 8.4 tomorrow, okay? So 8.3 and 8.4 are probably the big two sections for this third test. And also, well, I'm not seeing anything on chat. All right, y'all. So remember, practice for your test if you haven't done it yet, and get your test done by Sunday night. Also get started in your um test three material, okay? 8.1 and 8.2. So they shouldn't be too bad. I think the worst thing in 8.1 was doing that factoring the four-term polynomials, okay? All right, y'all, I'm gonna quit my recording.